So now let us understand the DTC structure and the format. So every DTC has a specific structure that tells us where the problem is and what type of fault or the problem it is and which system is affected. So if we talk about the OBT2 DTC format, so this is a standard DTC format and it is a given by the OBD2 rules, which is your SAE J 2012. The SAE is basically your Society of Automotive Engineer. So here the each DTC has a total of 5 characters, as you can see in this particular image. Okay, it is having the total 5 characters. Now the first letter, the first will be your letter and the next 4 will be your number. Okay, so let us see this particular example. So the first letter tells which system has a fault. So it is related to the system involved, means which type of system is getting affected. So suppose P, if you are getting P, it is related to the powertrain. Okay, and it will have the engine and gearbox. Okay, and instead of P, if you are getting B, then it will be your body, which will include your doors, seat and airbag. Okay, and similarly if you're getting C, chassis, so it will be your related to the suspension and brakes. Whatever component is related to the chassis or body, it will be having in like this format. Okay, brakes. And network communication means it is related to the data links between the ECU. Okay, so data links between the ECU. Now the next digit after this particular letter tells if the code is standard or manufacturer specific. If you are getting 0, which means it is a standard, and instead of 0 if you are getting 1, so it will be the manufacturer specific. Okay, now the second digit after the letter shows the subsystem like fuel, ignition and air, etc. Okay, so it will be a like affected system, and the last 2 digit, this particular will be your like a specific fault number. Okay, or a specific fault code. So here already we have discussed like P is basically your powertrain system, then 0. So in this case it is a standard code, not a specific to one car company. Okay, and 1 is referred to the subsystem. So for example, this is basically referred to your uh, air, fuel or ignition. Okay, now the 30, this is the exact fault. So in this case it is related to the O2 sensor circuit problem. O2 sensor circuit problem. Okay, so this is basically your related to the 30, the last code. So with just one DTC code, you can know the system standard or the custom code and type of fault or the problem and the exact problem location. Okay. So now here we will discuss about the UDS DTC format, which is based on the ISO 14229-1. So UDS DTC use a 24-bit 3-byte format. Okay, so this means they are saved as a 3 number or a byte together, not in the letter or digit like the OBD codes we have seen. Okay, so these codes are more flexible and a manufacturer can define them as per their needs and their requirement, and they are mostly used in the new ECUs or to update the diagnostic systems. Okay, So we will see the structure. So the first byte is your higher byte, which means it shows the main system group or the fault group like engine or transmission and brakes. Okay, this type of things you can understand from the first high byte. Then second byte tells the exact subsystem or the functions within that inside that particular main group. For example, ignition or the fuel injection. Okay, ignition or fuel injection. Now the third byte is the most specific, and this number tells the exact fault detail found by the ECU. Okay, so it will tell you the fault by the ECU. So for example, we have a DTC value 0 cross 1 2 3 4 5 6. Okay, so 0 cross 12 or this particular 12, it is a system group. For example, it is related to the engine, and 34, it is a subsystem and it is basically related to the ignition control. Okay, ignition control, which comes under this particular engine. Okay, now the last 56, it is a fault detail. So this is basically a specific fault detail. Maybe it is related to the sensor fault. Okay, so ECU stored these all numbers because it is a simple and fast for your PC, but your scan tool or laptop will be like it will show them in the meaningful way. Okay, and the text you can connect and you can read that particular code easy. So with the UDS DTC format, car companies can define many types of fault in the great way. Okay, and they can use this particular in the 3 byte for every DTC. So I think this is clear between your OBD and DTC, UDS DTC format. Now let's understand the main differences between the OBD2 and the UDS DTC. So OBD2 might only show a message like O2 sensor fault, but in the UDS case, you can give much more details like what happened, how often the problem happened, and what conditions were present when the fault occurred. Okay, so in this particular table, you can understand the basic differences between the OBD2 and the UDS DTC. So for example, okay, the standard. So OBD2 use the older rules like SAE J 2012 or ISO 15031, but whereas your UDS use the ISO 14229. Okay, now the format. So the format for OBD2 codes are a mix of letters and the numbers like P0130, but UDS uses only the 3 bytes informations completely as a number like 0 cross 1 2 3 4 5 6. Then focus. So here you can see OBD2 only looks at the emission faults, but UDS can report problem from any system, whether it can be your engine, battery, management system, ADAS, or anything related to that particular vehicle. Now the access. So OBD2 codes need the OBD socket in your car, but UDS code can be read using special workshop or the OEM tools. Okay, so this is the difference. Now the fixed identifier. So OBD2 has a set of codes, but the UDS lets car companies define their own codes as they need or as based on their requirement. Now data details. So OBD2 code info is quite basic. Okay, and UDS gives a lot of extra details like how many times the fault happened and more about each events. So the modern cars uses this particular UDS DTC for the uh, reading the more detail about that particular error. Okay, and they can give you the more detailed diagnostic which helps to solve the problem easily way.